Okay, this is a continuation from the last video. When I discharged this capacitor, my camera shut off. I guess those kind of things will happen. Okay, we're going to continue with this. I'm going to turn this back on. I had to check out the camera for a minute and see what was going on. I turned this beeping off. We're at 737 volts. We're going to try shortening it out and bring the camera a little further away. Now, something that's interesting here, once the capacitor gets charged at 750 volts, I've had it close to 900 volts. I'm going to turn the light off here. You can see the fluorescent. Now, when I hit this spark, watch the fluorescent. It gets brighter. And then as the capacitor charges, I guess it's a countering thing. As the capacitor charges, it depletes what's actually going out to the light bulb. We're going to short it out again. That's 700 volts. You'd think there'd possibly be a bigger spark from it, but if it's going that high, we're getting, a decent amount of current going in that we can get multiple pulses at some kind of reasonable voltage to dump into the transformer. But it's just a very, 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 very interesting way to charge a capacitor. From what the article says, we are able to charge the capacitor with enough energy that the source here isn't actually producing that much energy. It doesn't feel this as a load for as much as it's charging. Now, those are things I'm going to have to test, but a very interesting way to charge the capacitor. Either way, you could use the other leg to charge another capacitor and alternately discharge them into a transformer and get more power, I would have to say. So as one's charging, just as this light gets brighter when this one discharges, once you discharge the other one, this one will charge fast, that one will charge fast, and hopefully once I take some measurements. I just hooked this up. I needed to try it because they were talking about it. We're sitting at 755 volts. Not quite sure what the voltage is on this. I might have to get myself some very high ohm resistors and set them up in series so that I can read one of the resistors and calculate, how many times I have how many resistors, like a voltage divider, so I can read some higher voltages. But very, very interesting how that is. One wire charges the capacitor. Now, this is high frequency, some kind of neon transformer type deal. I guess any neon, you could go to auto parts store and pick up a really cheap neon kit for 14 bucks and play around with this. The transistors are cold. Now, if I hook up this thin bulb here, it gets really bright after a little bit. When I hook up this one to it, this thing lights up pretty good too. Those transistors are hot to the touch, can't touch them. So that's when you know that thing's working perfectly and the way it's supposed to, and how much power is going in is how much power is going out. But it seems that we could possibly, if I'm just touching the case of the capacitor, the light. So in this case, if you put a ground on that side, this capacitor might charge way over 1,000 volts. I'm not sure. Just experimenting with it now, but I just needed to show this as a part 2 of getting a capacitor charged, so I wasn't really satisfied with the way I was doing it at first. My next video is most likely going to be an improved selection of parts for the Tesla igniter patent circuit, because I was doing some experimenting with that, and it seems to be doing a really good job of charging the capacitor. I was going to show that tonight, but that's going to take a little longer for me to set up. This was very simple to do, and I think people should know how this works, because it could be a very usable function for a lot of things. And in the future here, we'll do a video of how much current we got coming out of here. And if we use this as a discharge capacitor on a transformer, we can see how much power we're going to get out. We'll get a relay and run it at 60 hertz, and get some real values from a normal transformer and see how it works. But very, very interesting. Um, if you have an old printer or scanner, the light in there, you're going to have these kind of circuits. And some of these boards, they have some little capacitors on there, excuse me, that are 1,000 to 2,000 to several thousand volts, depending on how big it is. But I thought that was very cool, and I wanted to show that. We're still sitting at 757 volts. But that's it, guys. The Arvmenco plug. This isn't something I've invented. This is something that I've seen, and I tried it. I doubted it at first, but I'm very, very, very impressed. Alright, guys. Good night.